Mm, uh, I'm going to talk about shared memory at GPUs. Shared memory is a fast, limited size memory accessible by all threads within a block. Not the threads of the grid, but threads within a block. Shared memory is faster than global memory, stores um, data at compute unit level or SM level. Shared memory allocation can be static or dynamic. Filing shared memory is done by the same. Filling shared memory is done by the same kernel calculating the stencil. Yeah, for in our example, we are using global memory and we first copy it to the global memory. We never allocated shared memory. And filling shared memory can be done by a block itself. Then block continue using the shared memory that it allocated. Um, yeah, that is important to understand. Threads in a block must synchronize to ensure all data is loaded into shared memory before computation begins, because threads in a block is going to load shared memory, then the same threads in the block will use the shared memory. Therefore, we need to be sure that shared memory is filled with the data before using it. That is the idea. Yeah, as you know, we created chunks, and we have a hollow size which is 1. And the chunks, as you know, might include more than one blocks depending on the block size. And kernel will install the data to shared memory, then use the data from the shared memory. And what is the size of the data to be copied to the shared memory by a block? As you see, block size here is not the same with the chunk size. But block is responsible initially to copy the data and the hollow data together with the hollow region and to the shared memory. Then block is going to process the data to find the next heat values. Here we can see that there's a block, for example, block 11 is going to install the data with size chunk plus 2 by chunk plus 2 and chunk width plus 2 by chunk width plus 2, and it is going to install shared memory. Then it's going to use shared memory to update the chunk at the global memory. And this is the idea, and we need to write a kernel which is going to allocate shared memory first. Although it is going to be created in the kernel, every thread is not going to create another shared memory, of course. This is the allocation of shared memory. I mean, Alpaca manages the allocation of shared memory. If one thread in a block creates the shared memory, then the other threads are not going to overwrite it. And we are going to wait for all threads in the block, in the kernel, to copy the data to the shared memory. Then we will start computing the next heat values. This is the idea. Initially, we are going to allocate shared memory inside the kernel. Yeah, this is a static allocation. Why? Because the size is given. Yeah, this is the shared memory allocation. And we are going to calculate the thread index, fill the shared memory by block of threads, then wait for the shared memory to be filled by all block threads. then calculate the new heat value using the data from the shared memory and set the new heat value. But you can ask that, okay, we are copying initially the data to the shared memory, and we are reading the data from shared memory, and this is an overhead. We are first copying the data to the shared memory, and is it worth? And normally, since each kernel needs 5 data, each kernel needs 5 data. If a kernel would only need 1 data, then copying to shared memory might be useless. But we are initially copying the data from global memory and shared memory. Shared memory is fast, and each kernel needs 5 data. For the next data, the same data used is also needed. Therefore, we don't need to go to the global memory for the already used data by the previous calculation. Therefore, this is important. If we don't have a stencil, we are just using one data and multiplying, for example, a data value with 2, then writing to the global memory. Then using shared memory would be useless. But we need 5 data, and when stencil slides on the data, previously used data is also being used by the next stencil operation. Therefore, this is important. If the heat equation, difference equation is a higher level equation, the stencil would be, for example, larger. Then using shared memory will be much more useful because we need much more data already used by the previous points. Therefore, this is an important point. Yeah, that is the idea. Maybe we can continue after lunch, or what's your opinion?